Good day, dear colleagues. For your attention, we present a report on the topic Peculiarities of the Decision-Making Support System Development in Conditions of Uncertainty. For centuries, people have been able to make decisions based on the one or two major factors to the exclusion of many others. They live in a world where the pace of environment change was slow and new phenomena appeared one after the other, not all at once. As for the present, uncertainty is an integral part of decision-making processes, which is associated with both the complete knowledge about the decision-making problem and vague understanding of the goal by the person making it. Therefore, the creation of the decision-making support system in condition of uncertainty will allow to improve the quality of the decision made, which will ultimately reduce the consumption of various types of resources in the process of the implementation. During the research, it was possible to determine that the process of decision-making in conditions of uncertainty, the methods of expert evaluations are most often used. This class of methods represents methods of organizing work with expert specialists and processing experts' opinions expressed in a quantitative and qualitative form with the aim of forming a body of knowledge for making managerial decisions. The analysis shows that there is no ideal method, and the choice of the one or another depends on the input conditions and the expected result. Given that, it can be concluded that in the implementation of this task, existing methods can be applied by adapting them depending on the input conditions, which is planned to be implemented in the design systems. The purpose of the study is to develop a decision-making support system under conditions of uncertainty. The conducted research will provide means of obtaining the subjective probabilities, values based on previous comparisons, and will allow to increase the reliability of the received information and assess the level of contradiction of the statements. The results of the research solve the actual scientific and practical problem of obtaining the subjective probabilities values, which are based on previous comparisons and allow the increase the reliability of the received information and assess the level of the contradiction of statements, which in turn will provide a mechanism to support the decision-making in conditions of uncertainty. In order to present the main aspects of the studied subject area, its conceptual scheme was built, which shown in figure 1. As can be seen from the figure, the key subsystems are the core subsystem, the knowledge refinement subsystem, the communication subsystem, and the pairwise comparison subsystem. In order to determine the interaction features in the design systems, the functional modeling methodology and IDF0 standard, which is intended for the formalization and description of business processes, were used. A context diagram reflecting the decision-making support process in conditions of uncertainty is presented in figure 2. Among the set of external entities of the design system, the following were highlighted: customers who form the tasks and goals of the project, in which important decision must be made, user interaction, with which allows the system to determine the needs of the project and its possible risks in more detail, project market, which provides information about existing projects and their impact. In order to detail the descriptive functionality, we will perform the process of the created model's decomposition, taking into account the specifics of the task. The decomposition diagram shows four main processes: the process of identifying uncertainty, the process of analyzing and evaluating the results of decision-making, the process of project planning and operational management, and the process of monitoring. The decision-making process using the decision tree generally involves the following steps: problems formulation, construction of this decision tree according to the standardized algorithm, assessment of the probabilities of environment states, establishing chains for each possible combination of alternatives, and solving the problem. The mathematical description of the specified process is performed using the algebra of algorithms. So the first stage of the implementation of the algebra of algorithms is the description of the unit terms and the synthesis of sequences, which is given in slide. Next stage, this is a substitution of the corresponding sequences in the elimination. Format unit terms, you can see on this slide here. The next stage, the substitution of the corresponding systems sequences in the elimination. In view of the given material, the process of logical derivation is based on finding the expected monetary values for each vertex of the decision tree. This subsequent comparison and and choosing the best strategy. Expected monetary value are calculated on the basis of such characteristics of nodes of the decision tree as probabilities of random events and loose profits from the implementation of the strategy, and they themselves become characteristics of the nodes. It should be noted that the final vertices of the tree, the values of the expected monetary values are initially set by the values of the prices of strategy implementations. The function that implements the specific algorithm is recursive. Is it the recursive traversal of the tree? When calling this function, the root of the tree is passed as a parameter. Next, the mechanism of logical derivation continues with the comparison of expected monetary values and finding the optimal decision-making strategy based on this comparison. The next stage was the development of the system using modern software tools. As a demonstration of the system operation, consider the abstract problem of winning the lottery. The user must make a decision either to buy or not to buy a lottery ticket. He's not sure whether the ticket will be no win, probability 0.5, small win probability 0.3, or maximum win probability 0.2. In the first case, the loss founds in the amount of 77,000. In the second case, the next profit will be 55,000. In the third case, profit of 200,000. For a fee of 10,000, the user can perform a mathematical calculation that will help them determine the probability of winning. Okay, next slide. After processing the next button, a window with an explanation of the results will be displayed on the screen. As a result of the analysis of the control example, we can draw the following conclusion that the process of building a decision tree is implemented in the form of sequence of logical interrelated questions, which helps the user to systematize his knowledge of the subject area and enter it into the system. As a result of the conducted research, the existing methods and approaches used in the process of supporting decision-making in conditions of uncertainty were analyzed, which made it possible to identify the peculiarities of their application and outlined the range of problems that arise. The general sequence of the main stages of the decision-making problem under condition of uncertainty analysis is proposed, and the justified feasibility of using of decision tree method for solving multi-step problems is processed. The structure and main components of the decision tree are considered, and the decision-making algorithm is formulated using the method of the same name. The influence of external factors is analyzed on the basis of which a method of obtaining the values of subjective probabilities is proposed, which is based on pairwise comparisons and allows to increase the reliability of the received information and to set the level of contradictions of statements. Further research will be directed to testing and improving the system, eliminating conflicts, and expanding functionality in accordance with the specific requirements. Thank you for your attention.